Right, thanks very much. So this is joint work with Peter Stuckey. And this is not a very technical talk, and I'm not going to tell you how to kind of make your problem solve faster or how to model problems that you didn't know how to model before, things like that. Actually, what I'm going to tell you is how not to model problems. That's the idea. So the goal is to help you write correct models, or at least debug incorrect models. And the approach that we're going to take is that we won't let you use integers. All right, so that's the idea. So don't model with integers. That's within reason, right? But that's what I'm going to show you. Okay, just brief overview of modeling languages, because that's the context that we're in. So in a modeling language, we can express optimization problems. Maybe we will focus on discrete problems in this case, because we're talking about integers. And we can translate those models into a form that's suitable for an algorithm to solve, right? And there are many examples of modeling languages from the MIP community. We have things like AMPL, GAMS, AIMS, and so on. From the constrained programming community, we have things like Essence, MiniZinc, OPL, which originally came more from the constraints point of view. So we're going to use MiniZinc in this talk. I'm going to give you an example where the task is to choose k products from a set of n products with a weight limit, and we want to maximize our happiness from choosing those products. So this is a MiniZinc model of the problem. So we have a bunch of parameters. For example, the number k, how many products we want to choose, the weight limit, the number of products we can choose from, and so on. And then we have a couple of arrays of these variables, and I'm defining a set here, just a set of integers to kind of abstract from that set of products. And then we have some parameters that are coming in from the outside, some data that's coming in. For example, for each product, we have the weight, which is an integer, and we have the happiness that we derive from choosing that product. And then the decision variables in our problem are an array of size k. So we want to choose k products, and each of the variables is the product that we choose at that position k. And we want to make sure that we choose k different products. That's the O different constraint here. So pretty straightforward. And then we have another constraint here that is actually quite interesting from a modeling point of view. So basically, we're adding up all the weights of the chosen products, and we're making sure that that's within the limit. The constraint we're using here is the variable lookup. So if we look at this particular bit here, we're indexing into this weight array using the ith chosen element, right? Where chosen is actually a decision variable. That's what we want the solver to determine. And we're using that variable to index into an array, right? That's the element constraint in the constraint programming framework, but we can also map that into a mixed integer formulation or into a set formulation, right? And then we have a objective function at the end. Right, so this model works. You can type it into MiniZinc, feed in some data, run it, and it'll give you a solution. So what's the problem with that? Well, unfortunately, when the model starts working, that's when the real problems begin with debugging, right? You might have too many solutions, so solutions that are not actually solutions to your problem. You might have to debug that. You might have too few or no solutions, right? The solver might just say, this is unsatisfiable, even though you know that there should be a solution. You might have to debug that. Or what's really the worst case, there might be no answer at all, right? The solver might just take half an hour and not come back with any solution, or days and not come back with any solution. And then you don't know whether that's a bug in your model or whether the problem really just is too hard to solve. All right, and there's not a lot of debugging support. Most of our solvers are kind of black boxes. They're difficult to understand. Every solver is different, right? Once you've learned how to debug with the constraint programming solver, that doesn't tell you much about debugging for a MIP solver, potentially. You may be able to look at some of the internal stuff like search trees, but they might be really big, so that doesn't tell you much either. And the solver level representation, so the input to the solver, is very, very different from the high level model that you wrote. Right? So even if the solver tells you there's a problem with like these 100 variables, how do they actually map back to the variables in the model? How do the problems map back to the constraints that you wrote in your high level model? So the takeaway message here is that it's really, really helpful if the compiler can tell you there's a bug in your model before you even start handing that model to the solver. Right, so we want to just catch bugs in your model as early as possible. So to do that, we have to talk about integers. right? They are absolutely ubiquitous in discrete optimization problems, right? That's the key mechanism we use to model discrete problems. And we use integers to represent all kinds of different things. For example, we use integers to identify the objects in our problem, right? So if in a vehicle routing problem, we might number our vehicles from like 1 to 10 if we have 10 vehicles. We might use them to model the position in a packing problem, right? Where we put a square in a packing problem, things like that. The start time in a scheduling problem, or the order of visits in a vehicle routing problem. Right? For all of that we use integers. And our proposal is to stop using integers for these things. Okay, and the answer is not like technically deep or very new or anything like that. It's just enumerated types. Right? Enumerated types are a feature in many programming languages. Basically, once you define an enumerated type, it gives you like an explicit, distinct type for a set of things, a set of objects. And then mixing objects of different enumerated types is a static type error. That's the whole story. In MiniZinc, we can replace integers with enumerated types in models. And then, of course, MiniZinc will translate them back into integers for the solver, because solvers don't know how to deal with enumerated types. And again, this is not even new in modeling languages, right? So some languages have some support for enumerated types, but maybe not as strict as they are in MiniZinc. Okay, so let's look at the model again. And all I'm going to do is I'm going to replace that integer n and the set of products with an enumerated type there. All right, that's the only change I'm making. And now suddenly the compiler complains because it says this here is a type error. You're trying to index into the happiness array with an integer, but happiness is indexed by products. So this is a type error. And actually, if we look at this, that objective function makes no sense, right? We're adding up the happiness of the first k products, right, in the previous case, which didn't even depend on any decision that the solver made, right? So this is clearly complete rubbish. We would just get basically a constant objective value every time. But it's very hard to actually see that, right? These kinds of bugs are incredibly difficult to find because the solver will give you a solution. It will look like a correct solution. It will satisfy all the constraints. It just definitely won't be optimal. Right, and we can fix this by just saying happiness of chosen of I instead of happiness of I. All right, so I think I'm going to skip over this a bit. So enumerated types have like all the usual operations. The important thing is that comparison and array access between different enumerated types is a static type error. Right, that's the advantage. We do some automatic coercions that we might get rid of to make it even stricter. So the main part of the paper is really type extensions and defaults to make enumerated types a bit more expressive than they were before. So this is another little toy problem that we came up with that was part of MiniZinc challenge a few years ago. And so we're trying to use kind of buy one, get one free vouchers to buy pizzas. As you have a bunch of these vouchers, and if you buy a pizza and use a voucher, so if you pay for a pizza and use a voucher, then you can get another pizza that's cheaper for free. So the way this is modeled here is that, well, we have a set of vouchers and we have a bunch of pizzas, and for each pizza we say how we pay for that pizza. We use a really funny encoding here where we say if the value of this how value for a pizza is minus j, then we get that pizza for free by using voucher j. And if it's plus j, then we're paying for the pizza and activating voucher j by that purchase. And if it's 0, it just means we buy the pizza and don't use a voucher. So this is convenient because then we just have a single variable that tells us how we use the vouchers, and we can represent the main condition that the price of the pizza we pay for has to be higher than the price of the pizza we get for free. But it's not very type safe, and we actually had bugs in this model before because of that. So the enumerated type version of this could look like this, where we have now an enumerated type for the vouchers, and then we introduce a new enumerated type for how we pay for a pizza, or how we use a voucher for a pizza. And we construct this type as basically 3 different options. The first option is that we get the pizza for free using a particular voucher. The second option is that we don't use a voucher at all. The third option is that we pay for the pizza and activate the voucher that way. All right, and then the the actual condition on when we can get, or when the price has to be higher than another one. I'll come back to that in another slide. So that's the main way we can use these extended enumerated types now. So we add these constructor functions f and b, which take us from the type of vouchers into the type of the use enumerated type. And we also add the partial inverse functions, f to the -1, b to the -1, that take us back from the use type into the voucher type, but only if the use object we're looking at is actually of the type f or of the type b. And we add a new constant into the type as well here. And this makes programs more type safe, or more concise. Well, it's shorter, not necessarily easier to understand depending on how complicated the expression is, possibly more self-documenting. So let's have a look at this part again. How does this work now? Well, we're saying if how of P2 is equal to f of b to the -1 of how P1, then the price of P1 must be greater than the price of P2. So what does that actually mean? It means, well, this function here, b to the -1 of how P1, it returns the voucher v if how of P1 is equal to b of v. All right, so it takes us back from this, how are we using the voucher type, into the voucher type. So it returns the voucher, but only if this expression holds, only if it's actually one of these b uses. And then f just constructs the f version of that voucher, and then we're checking whether how of P2 is equal to the f version of that voucher. So basically it means if we're using this voucher v to get P2 for free and to buy P1, and then the prices have to be, well, P1 has to be greater than price of P2. Now this is a bit complicated to reason about. You get used to it after a while. We're proposing new syntax that just uses basically case expressions. So you could just use a matching here where you say, okay, if this matches, if how P1, how P2 matches b of v, f of v, right, then the prices have to be like this. So that would be really nice. This is vaporware. This doesn't exist yet, right? But that's something that we will be working on and hopefully get to work. All right, the implementation is nice because we can just basically translate this back into regular MiniZinc by just introducing the functions and the additional enumerated types and so on. So it's not actually that difficult to implement. The other thing I want to show you is something that also comes out of these extension types. It's a separate functionality, but it's really useful in combination with these extension types. So here's a vehicle routing problem with the usual representation where we have a set of customers, and then we have these nodes that we want to put into this giant tour representation, which means that for each of the trucks, we need a new node for the depot location, because we want all the tours to go back to the depot and then the next truck leaving the depot and so on. So the nodes are customers plus starting locations for the trucks and the end points for the truck tours. And then that makes it a bit difficult to now do things like reason about the distance array, right? So we have a distance matrix here, or travel time matrix, that talks about locations, but now we need to kind of relate it to the nodes instead, right? Because the locations for the customers are given, the locations for the start and end points of the trucks are the depot. So we have this funny syntax here where we say, okay, if n is a customer, then it's the location of that customer, otherwise it's the depot. And that's just a bit inconvenient. So instead, you can use the new default operation, which just says, if x is defined, then the value of this is x, otherwise we have the default value y for something that's undefined. And that makes it a lot easier to write this, because we can just write, well, we look up the location of n as a customer. If that doesn't work, take the depot. Right? The same for the second part. We look up the location of the next node as a customer, otherwise use the depot. All right, and again, this is not too difficult to implement, and we can actually generate a really efficient implementation that doesn't really use an if then else, like which would result in a disjunction, but that just translates it into a larger array and just a direct array lookup using element constraints. So that's really quite efficient. Okay, so just looking at enums, these are really useful. So we looked at 129 models that were part of the MiniZinc challenge over the last few years, and 15 of those could benefit from using these extended enumerated types. 64 could benefit from just using enumerated types in general. And using default expressions, we can even make some of them run faster. So there's a 25% improvement in solving efficiency if you use defaults and this kind of extended array syntax in a clever way. All right, just before, like this is new stuff, this is not in the paper, but I think this is really interesting, and we don't quite know how to do this yet, but I think if anyone has strong opinions about this, I'd be really interested to hear them. So I said we want to get rid of all integers, but there's still integers in this model, right? So for example, we have the weight and the happiness are integers. So I just made a tiny change in this model, right, where I said, okay, now I'm summing up the happiness, and I'm saying that has to be below the limit. But this doesn't make sense, right? Because we're summing up happiness, but the limit is about weight. There's still a type error in this problem, right? I'm still comparing two integers that really mean two different things. So what we would like to do is add unit types into the system so that we can say, okay, the weight limit is actually in, let's say, kilograms, and the happiness is in smiles or whatever. I don't know how to measure that, but no matter how you measure it, it'll be wrong to compare the two, right? So this will now be a static type error, right? And that's the point. So we want to add unit types that automatically make these things incompatible. It's a bit more tricky because some things get a bit less concise to write down. So we're going through lots of examples and so on, but if anyone has interesting ideas about this, we'd be very happy to hear that. All right. Again, this is paper where this exists on paper pretty much. Okay, so I think I made up some time so we can have the photo and lunch. So the aim is to remove all models, just to make them more type safe and make sure that if there's a bug in your problem, you realize when you start compiling rather than after running the model for an hour or something like that. And the crucial thing is that objects should be represented using enumerated types, or the identity of objects. Parametric data should be given kind of unit types to make that type safe. And we hope that this, well, we know that this improves type safety, right? That's very clear. Possibly this also improves kind of the self-documentation and how easy to comprehend a model is. And that depends on kind of whether you use them, whether you use these types in the way they were intended, right? Because you can always mix them in ways that will make it look not that clear, but that's the idea. Right, and this is available in MiniZinc, so you can download it and it'll work. And that's it. Thanks.
Question online. There's question also in the room. The first one was Edmund.
The online was first solution.
Okay, so Helmut asks, what about I/O with these extensions? So that's a good point. So sometimes when, for example, when you have data that's coming in from, let's say, a database or a spreadsheet or whatever, you have to kind of define the conversions. That's not too difficult. With the unit types, I think we know how to do it. So we'll just basically say, you'll just define that the incoming data is kilograms or smiles or whatever. With enumerated types, yeah, you can either just load them directly from integers or use, for example, string identifiers, which is quite common. So that works. What impact does representing as enumerated types have on the efficiency of finding a solution? Yeah, that they are completely free. So the idea is this doesn't change. Like, all we're doing is we're rejecting models that are incorrect, right? But basically after that initial, like after 50 milliseconds within MiniZinc, the enumerated types are gone and the rest of the system just deals with integers. So the model that the solver gets to see is identical to the model that it would have seen without using enumerated types.
So why was it that you said that it's more efficient?
Okay, so that was not so much, yeah. So why did I say that one of the bits was more efficient? This wasn't so much about enumerated types. This was about this default operation, because there we can actually replace a disjunction where you say, okay, if this is a customer, then use the customer location, otherwise the depot, which we would have to compile as a disjunction normally, we can compile that into a more efficient array access by basically creating a new array that contains depot locations at all the places where the new elements are in the new enumerated type. So it's basically a modeling trick where you create an extended array that you can then just use an element constraint into, rather than.
Why can't you do that in the original?
Oh, you can. You can do it manually. You can just.
No. I mean, why couldn't the compiler do it automatically in the original?
Without the. So the question was why the compiler can't do it in the original.
And the original are kind of, you can map back and forth, sort
yeah, we might be able to do it in the original as well. It's a bit harder because it might be possible, but it's a bit harder. Yeah.
So is there maybe a small danger when you use the default that something else might be undefined than what you were counting on being undefined?
Yeah, that's a good. So the question was whether default is a bit dangerous because there might be something else that's undefined. That's true.
But I thought also, like, because in this case, I thought of this because the default is kind of on the outside, right? It's moving to the inside.
You can't move it to the inside in this case. So that's true. You have to be a bit careful with where undefinedness might occur. Yeah, that's true.
Also, I wonder whether you could have more octo, because some of those constructions, you sort of know the types, right? So there should be a way of doing auto, so they don't have to put all those C's and stuff.
Whether we could make some of those coercions automatic, so you don't have to write the C or C-1 or something like that. We've thought about that.
So
It's really hard. So it's exactly that problem that you might get back into the position where you're introducing type errors. So I think it's better to keep it explicit, but yeah.
So if you have more questions, sorry, it will have to wait after the photo.
Yeah.
Thanks again.